Welcome to Lesson 1.4, Undefined Terms and First Definitions. So after Lesson 1.3, where we explored some other types of geometry, now we are coming back to Euclidean geometry and our standard geometry that we use. And we are going to look at this concept of first undefined terms. So, as we all know, math is definitely a subject of rules and laws and equations, and you generally can't take things for granted and need to justify every step along the way. Well, this is one of the weird exceptions to that. There happen to be three geometric terms that we consider undefined terms. Now, yes, we have descriptions for these things, like how a point can be described as a dot with no thickness and does not take up space, but we don't have an exact definition. Same with a line, same with a plane. We know a line is a series of points that go on forever, but beyond that, really, how do we define it? We can do further descriptions, but there's not one set definition. Same with a plane. We know some properties, like planes are going to be a two-dimensional plane, or three-dimensional, there can be, but we know a plane would typically be a flat surface. We know a line will measure 180 degrees, and go on. But again, there's different descriptions. So these three terms are the building blocks of all of our other defined terms. And these provide initial reference which other terms can be defined. So if we did not agree on a point, a line, and a plane, then all of our further definitions in geometry would basically be useless. So we know how to describe points, lines, and planes. We know their properties. We just can't come up with a set definition. So those are three undefined terms, meaning we can use them as reference in other definitions. For example, a figure. A figure is simply a set of points. Can figures make shapes? Sure. A square is a figure. Triangle is a figure. Do figures have to be necessarily what we consider shapes? No, they're just a set of points. Space would be the set of all points. So all points in existence, the set of those, would be what we call space. A plane figure is a set of points that are all in one plane. So a plane figure would be something that we could simply call a two-dimensional figure because it's all in the same plane. So a plane figure set of points are all in one plane. Then, we've already briefly touched on these definitions, but collinear, co meaning again together, collinear on the same line. So three or more points on the same line. Three or more points together on the same line. Coming from that prefix a co. Same with coplanar, prefix being together. So together on the same plane, which would be four or more points that are on the same plane. So collinear, three or more points on the same line. Coplanar, four or more points on the same plane. And again, a plane is basically a two-dimensional flat surface. So if we look at that and we start to apply some of these first definitions, many more definitions that we'll get to throughout geometry, These are just some of the first ones we're looking at. So we're using these three undefined terms, point, line, and plane, to make up our definitions of a figure, space, plane figure, collinear, and coplanar, just to start. So then we have a cereal box example. Drawn three-dimensionally, obviously, only 2 dimensions on a piece of paper, but it looks three-dimensional. We know a cereal box is three-dimensional in real life. Now, to think of a plane, just think of that as one singular side of the box. So one plane would be the front, another plane would be the top, another plane would be the left, bottom, right, back, and so on. So each individual side of the box is a plane. Then, part A asks us, name a set of 3 collinear points. So I need 3 points on the same line. Yep, can't use DC, only 2 points there. Same with AB, same there, same there. Here we go. We have 4 points on this side, or this edge seam right here, of B. I believe that is J, I, and G. So in that case, B, J, I, and G. So then any of those 4 points, we only need 3, but any of those 4 points are all on the same line. Then name 3 sets of 4 coplanar points. So 4 points on the same plane. So the first thing I think of is the top. So points A, B, C, and D make up that set, 4 points on that top plane. Then we could do the side that we can see, A, D, E, and F, 4 points in the set. And then the front would be A, B, G, and F. I'm just taking the 4 corners, but I could also have used A, B, J, and G, or A, B, F, and I. Those are all on that front, so any of those would work. All right. Then moving to C. C says, are the points A, F, I, and J coplanar? So I have A here, F here, I here, and J there. Are they coplanar? Well, they're all on the front of the box. Yeah, it would make kind of a funky shape if we connected them. Almost a weird looking trapezoid. It is technically a trapezoid. But in that case, they're all on the front of the box, meaning the same plane. So yes, they are coplanar. Doesn't matter if they're the 4 corners, if they're on the same plane, they are coplanar. And then we have our definitions of dimensions. So these are things you've always referenced or talked about since you've probably been discussing shapes. But our simple definitions. One-dimensional refers to when all the points in a set are collinear. So that would be a line or a line segment. Those are one-dimensional. Two-dimensional would be when all the points in a set are coplanar. So that could be like the top of your desk or a tabletop. Could be a side of this box, things on a sheet of paper. So two-dimensional is when things are on the same plane. Three-dimensional is simply defined when all the points are not collinear or coplanar. So points exist that are not collinear and not coplanar to each other. That would be our 3-dimension, or our 3rd dimension, 3-dimensional. So example 2 asks us to classify each of the following objects. So the classification would be 1-dimensional, 2-dimensional, or 3-dimensional. Those words would be our classifications. So I abbreviate it to 2D, 3D, 1D. I'm fine if you do the same. So the first one we're looking at is triangle SUT. Triangle, all points are on the same plane, so it's two-dimensional. Now, an ice cream cone, obviously printed, it's a 2D image, but if it was an ice cream cone in real life, definitely not all the same plane or the same line, so that would be third dimension, three-dimensional. Then our line, a line is always one-dimensional, and a basketball is spherical. Anything that's spherical definitely has points that are not collinear and not coplanar. So that would be three-dimensional. So the classifications of one-dimensional, two-dimensional, three-dimensional, just a brief review there and putting a more, I would say, concrete definition to them now that we're in geometry. And then going back up, we have the ideas of collinear, meaning they're on the same line, coplanar, on the same plane. So collinear and coplanar. And then a few other first definitions of figure, space, or plane figure. And our three undefined terms of a point, which we again could describe typically as a dot that does not take up space and does not have size. A line, which would be a set of points going on forever in opposite directions, which does not have a thickness but has a length. Or a plane where everything has, or exists, I should say, in the same two-dimensional space. And the plane would be something like a tabletop or a sheet of paper. So planes have that going for them as far as descriptions. So now point, line, plane, no exact definitions. We use these as foundations to build into bigger topics.